Right. So earlier we were focusing on the devices that is involved, and also we
Mm-hmm.
were talking about VLANs. Now
Yep.
there is a protocol called ISL
Mm-hmm.
and .1Q.
801.q.
Hmm. .1Q is what the name given, but it is actually
Mm-hmm.
IEEE 802.1Q.
Okay.
.1Q. It's a standard, but the name of the protocol is also given with the same standard ID like .1Q.
Okay.
IEEE 802.1Q. This protocol is based on this standard. So this .1Q has
Okay.
become a name. Now,
Okay.
this ISL inter-switch link, this inter-switch link ISL has got two meaning in networking world. One, the protocol ISL which we are talking now. The other one is
Mm-hmm.
people will say ISL meaning the link between two switches.
Mm-hmm.
So they some take literally this as a terminology to explain a connection between two devices. But it is
Okay.
also a name given to a protocol in the beginning.
Mm-hmm.
Now this protocol is not that popular, lost its importance. So um, we no need to have any confusion here. Here today, if ISL means it is only the link that they are talking, not the protocol ISL, because the protocol ISL is no
Okay.
more in picture. Now, what is the purpose
Mm-hmm.
of these two protocols? They are called as trunking protocol.
Mm-hmm.
Now, we learned that combining ports of multiple switches in one broadcast domain is possible, but for that we need a connection that we make between the switch as a trunk port, trunk link, a trunk link. So this port and this port, when I make it as a trunk port, when we make a
Mm-hmm.
port as a trunk port, how do we make? Just configure it as a trunk port. Any port can be
Mm-hmm.
made as a trunk port. There is no specific
Mm-hmm.
dedicated port type. Any port that is
Mm-hmm.
available to connect between the switch that you decide to connect between the switch can be made as a trunk. Mostly people will try to
Mm-hmm.
connect the last two ports like F24, F24. Fine. So now we got a trunk port and a link that connects to the trunk port. We call it as trunk link. Now this trunk port's job is to add the VLAN information to the frame that goes out so that the receiving switch, as they receive the packet in, by looking into the VLAN ID, they will know to which broadcast domain they need to forward. So
Mm-hmm.
we got a computer here, one or two computer, the computer here. These three computers belong to a blue VLAN, VLAN 10.
Mm-hmm.
And there is another computer here and two other computers here. This belong to a brown VLAN called VLAN 20. Now,
Mm-hmm.
We want this blue and blue to talk, brown and brown to talk, and we got
Okay.
a trunk link to pair them. Like whenever this brown shoots a packet out, it only comes to this brown. Say, for example, a broadcast is sent. It only comes to
Mm-hmm.
this broadcast domain member on the other switch. It won't go to other VLAN members.
Okay.
It won't go to
Mm-hmm.
blue. The reason is this protocol. This protocol makes sure these two protocols take the guarantee of knowing, letting know the next switch who receives the packet to which broadcast domain the packet needs to be forwarded. So if the brown shoots the packet comes out
Mm-hmm.
and it adds the VLAN ID 20. That's the job of this protocol, trunking protocol. It adds the VLAN
Mm-hmm.
ID to the packet so that the receiving switch will know that the packet belongs to 20, and after knowing it is 20, it removes that VLAN ID and forwards only the packet. So to know to which VLAN I need to forward, the switches will look for the VLAN ID on all the incoming frame.
Mm-hmm.
When a packet comes
It
in,
will be in the the VLAN ID will be in the link.
we'll talk about that.
Sorry, in
It,
the
it's
second layer.
it's going to be
Okay.
in the packet where and all we'll talk. When we talk about the difference between these
Okay.
two protocols, when we talk about the difference
Mm-hmm.
between these two protocols, I will explain that because they do in two
Okay, sir.
different way.
Okay, one more question, sir.
Yep.
Is that a single interface can be added in two different VLANs?
No,
Okay.
no. And
Okay.
a trunk port is a member of all VLANs, but your
Mm-hmm.
question is not a trunk port. You are talking about an access port. What is an access
Mm-hmm.
port? That the port belong to a single VLAN. A port
Okay.
that is a member of single VLAN, we call it as access VLAN, access port. No access ports can partake in two different broadcast domain. Not possible. One port,
Mm-hmm.
one VLAN. They
Okay.
cannot be a member of multiple VLAN. They cannot be.
Mm-hmm. Okay. So
Fine.
what I thought was the
Port.
access port is something when a switch connects to a end device like a computer, laptop, or anything.
Hmm. That is also true.
Is that wrong?
No, you're right. Access port is a
Mm-hmm.
port that connects to the end device. That is true. That's the
Okay.
most use case
Okay.
that we have. But
Mm-hmm.
we may also have an access port connecting to a router. We may also have an access port connecting to a hub. We may also have a access port connecting to another switch. See,
Okay.
if I don't have VLANs and this switch is only 24 port switch, and
Mm-hmm.
assume there is no VLANs. I don't want
Mm-hmm.
VLANs. I want almost 30 people to be a member of same VLAN. So what I will do,
Mm-hmm.
out of 30, I'll connect
Add
15
one.
of them here and 15 of them here.
Mm-hmm.
I'll connect this link. This port will be definitely a member of same VLAN to which this 15 and this 15 belong to, which we call it as
Okay.
access port. Yeah.
Mm-hmm.
So it is not always between switches you should have trunk. It's not
Okay.
mandatory unless it is necessary,
Mm-hmm.
not mandatory. So access port,
Okay.
as a layman definition, you can say a port that connects to end device. But when we say that, then this will go wrong. What I said just now will go wrong. So,
Mm-hmm.
do you need same broadcast domain to be extended to another switch? And you don't
Okay.
want multiple VLANs to use the link? Then you can
Mm-hmm.
have access port. Even if I have multiple VLANs like this, and I don't want a shared link. I don't want a shared link. I want a dedicated link. Then I'll give for VLAN 20 one link, and
Mm-hmm.
for VLAN 10 another link. But this is practically not possible, because if I
Yes,
have
but
100 VLAN, then I need to spend 100
mm-hmm.
interface only for connecting. Practically, it is not
Mm-hmm.
possible to use in the production. It will be very costly, but that is also available. So you can avoid trunking completely by giving a dedicated link for each VLAN. Then you will have a
Mm-hmm.
dedicated bandwidth for each VLAN. This is a shared bandwidth now. When you have trunk, all
Yeah.
VLAN members need to use the single link to talk to the other switch. If all the VLAN members
Mm-hmm.
send the traffic at the same time to other switch, what will happen? There will be a congestion here. Yes or no?
Mm-hmm.
Yes.
Yeah,
There
sure.
will be a congestion on the trunk link. So when you feel like, oh no, I don't want this congestion to happen, then let me give us dedicated uh, links for each VLAN. Then there is no trunk, all are access.
Mm-hmm.
So access ports can
Okay.
also be between the switches. Now
Okay. I got it.
let us go back to where, this trunking protocol will tag the traffic before sending it out, and the switch that receives will look for the tag, and when it finds the tag, it knows to which VLAN it needs to forward. Okay. Now, this is
Mm-hmm.
the right time to learn what native VLAN means. What is a native VLAN? Every trunk port looks for a tag in the incoming frame as they receive this frame. If the frame don't have a tag,
Mm-hmm.
if the frame don't have a tag, what this ISL will do, inter-switch link protocol will do, it'll drop. I am a trunk port.
Okay.
I need a tag,
Mm-hmm.
but the tag is not there. Then I'm not going to take it. I don't know to which VLAN I need to put. I don't know what VLAN I have to put, so I'm not going to take it. That is the way ISL behaves. But .1Q has something called native VLAN. .1Q has something called native VLAN. What is that? If in case there is no tagging in any of the incoming packet, I will send all those untagged traffic to this particular VLAN. You can configure any VLAN, uh, maybe 999, unused VLAN. You can create one VLAN and
Mm-hmm.
say unused VLAN,
Mm-hmm.
uh,
Mm-hmm.
and you can define it as native. Switchport
Okay.
trunk native VLAN
Mm-hmm.
999. When you configure
Mm-hmm.
a native VLAN as 999, whenever trunk port receives an untagged traffic, trunk port knows to which VLAN it needs to forward. It forwards to this 999 that you have specified. But you all know, we all know that there will be only one VLAN by default. Is it true?
Yeah.
Partially true.
VLAN 1 is always considered as the default name.
Yeah, VLAN 1 is always having the name default. The name default cannot be changed, and this VLAN number 1 cannot be deleted. So you cannot create. There is no need for creating. It will be always there. You can't delete. You cannot change the name also. The name default is only for VLAN 1. But by default, there will be 5 VLANs. In any switch, as per the industry standard, there will be 5 VLANs by default. 1004, 1001, no, 1002, 3. They're all for token ring and FDDA, something like that. No, but our Cisco switches don't support it. But it is there. There will be 5 VLANs in database by default. But the VLAN number 1 is what called as a default VLAN. Now, because you don't have 999 in the database, when you don't have native VLAN specified by the user, if I don't specify this 999 as a native VLAN, then this VLAN number 1 will be used as the native VLAN if you don't mention. The default VLAN itself is considered as a native VLAN when you have .1q as a protocol. If the trunking protocol is .1q, as the packet arrives, the trunk port looks for VLAN ID. There is no VLAN ID. Then let me push that packet to let me put the packet to VLAN 1 because there is no native VLAN configured. But when I configure native VLAN, untitled traffic will not be sent to VLAN 1, it will be sent to 999. So that's the purpose of native VLAN. There are three types of VLAN, people will always confuse us during the interview time. One is this default VLAN. Now you know what is very, very well what it is, and then you also know what is native VLAN. The third one is Cisco's private VLAN. Later we will see private VLAN, not now. Now, where are we? So we got a trunk link. Now this trunk link needs a protocol so that the VLAN tags can be attached before sending, and VLAN tags can be read while it is received. When it is received, we need a protocol. That is where this ISL and .1q comes. This ISL is a Cisco protocol. So no one knows about ISL as a protocol outside Cisco. So outside Cisco, ISL is not a protocol, it is just a term to explain, to describe a link between two switches. But as a protocol, what is the difference between this .1q, which is also a trunking protocol, known to everyone because it's an industry standard, IEEE standard, it's known to everyone. Both does the same job, then what is the difference? Again, I'm telling you, this is only for knowledge. It's not going to be useful for you. ISL is, even Cisco doesn't respect this ISL anymore. Their own protocol. They don't really use anywhere. Some switches, they don't have this option of ISL. Not some switches. Most of the switches don't have an option called ISL. Earlier it was there. Now,
Mm-hmm.
But let us understand why ISL is now totally gone. What is the drawback of ISL and
Okay.
what is the good thing in the .1Q? .1Q uses just 4 bytes maximum. 4 bytes
Mm-hmm.
to tag. See, actually, VLAN,
Mm-hmm.
it's only like for VLAN you got 12 bits.
Mm-hmm.
It's less than 2 bytes. For
Okay.
VLAN marking, the number of bits given is less than 2 bytes, 12 bit.
Mm-hmm. Okay.
But for a few more markings, there is a reservation of 4 bytes in total. 16 bits,
Mm-hmm.
32 bits, 4
Oh,
byte. Maximum of 4
okay.
byte is what .1Q will use for tagging. So only 4
Mm-hmm.
byte of additional bits get added if .1Q tags.
Mm-hmm.
But
Okay.
when ISL tags, it will use 32 bytes,
Okay.
in which only 12 bit is VLAN. Only 12 bit is VLAN.
Mm-hmm. Mm-hmm.
So 32 bytes, only 2 byte is going to be properly utilized. And what happened to other 30 bytes?
Mm-hmm.
It is not 30 bits, I'm talking 30 bytes. This additional 30 bytes will be full of junk value. Why we call it as junk values? Because it is 32 byte .1Q users, every packet 32 byte will be processed by all the receiving switch to know the VLAN ID. That one
Mm-hmm.
VLAN ID, to know that one VLAN ID, every switch needs to process the
Mm-hmm.
32 byte. Only then they will know what VLAN the packet belonged to.
Mm-hmm.
Whereas in .1Q, they read only 4 byte information to learn to
Mm-hmm.
which VLAN the packet belonged to. So, what do we understand in this? The amount of process utilized by ISL will be higher, big, more.
Okay.
So,
Okay.
comparatively, .1Q is faster
Mm-hmm.
in adding VLAN and removing VLAN and processing because it's small size. Secondly, .1Q will be adding that VLAN information right in the layer 2 header. This is layer 3 and layer 2 and layer 1. .1Q adds the VLAN ID by decapsulating before sending, decapsulates the packet.
Mm-hmm.
It inserts the tag inside and again
Mm-hmm.
encapsulates and it will send it out. On the receiving switch,
Okay.
when they decapsulate and read layer 2, they will know the VLAN ID. After knowing VLAN ID, they remove the VLAN ID, encapsulate it,
Mm-hmm.
and send it to the host without any VLAN because hosts don't understand VLAN. The packet will be simply sent into broadcast domain and to the port
Mm-hmm.
in the broadcast domain to which the destination MAC address matches. And packets get delivered. So .1Q adds the label in layer 2. Then how ISL will do? ISL is not going to do like this. ISL
Mm-hmm.
will encapsulate with the new header called ISL, which is 32 bytes of information. It encapsulates, it's not adding right in the layer 2 in one of the field. It encapsulates the layer 2 field completely. It's not the way I should draw. I should draw like this. It encapsulates, it's not inserting, it encapsulates additional layer. So this is also a difference. Encapsulating, insert. Yeah. So the main difference is the size of ISL is 32, which is not really good for the switches that process to just to know that 16-bit value. 12-bit actually. 12-bit value, which with priority to 16-bit. So .1Q is the best. .1Q is what widely seen. ISL you cannot even see in Cisco devices nowadays. In the older device, we had an option to choose ISL or .1Q. Another big difference we saw is there is no native VLAN in ISL. ISL, if a packet is received without VLAN ID, ISL is going to drop the packet.
It drops.
.1Q can put it in some VLAN which you specify as a native VLAN. If you don't specify, it will put it into the default VLAN number 1. You can see these things by typing show interface trunk. You'll see native VLAN by default 1 there. But we can change it.
Okay.
Have you tried changing it before?
Native VLAN?
Yeah. No, let me quickly. Let us take to switch now 1 and 2. This I'm going to configure as a trunk. In this switch, I no need to even define encapsulation trunk, sorry, .1Q, because by default there is only .1Q. But in some switches, you have to mention the encapsulation type. Have you seen that?
Yeah.
Yeah. Switchboard trunk encapsulation .1Q is needed in some switches, but in this switch, it's not necessary. Switch underscore B. I'm just naming it as switch B, and this one is switch A. Now show interface trunk. There is no trunk link because by default all ports will be in an access mode operationally. We'll talk about the differences and all those things later, like access port, trunk port, dynamic auto, dynamic decider, and so on later. Now we are going to configure trunk on F00 on one side, interface trunk, interface F0/1. On switches, you no need to say no shutdown to interfaces. By default, all Cisco switches will have the interface up. Not only Cisco, even other vendors are having up state if they are only layer 2. Layer 3 supporting switches, in some vendors they are in down state, but in Cisco layer 3 supporting catalyst switches, they have ports up by default, because by default they are switching, not routing. Now, for security reason, routers ports are shut down unless you enable it. They don't route any packet. They don't process anything. They don't route any packets. Now, we are going to configure as trunk. switchboard mode trunk. That's it. Now, when I configure this on one side, the other side gets configured by default through the negotiation. It's the same .1 queue which is going to negotiate, and when both sides decides to use the same .1 queue protocol, the negotiation is successful. They form trunk. Boom. Now it's trunk. Let's go and verify. Show interface trunk. You can see here .1 queue is the encapsulation type. The trunk mode is on, and right now it is trunking. It is ready to support all VLANs. Means it's ready to carry all VLANs, but presently we have only one VLAN because we have not configured any VLAN. And you see the native VLAN. The native VLAN is 1 by default, and if you will change this to 10, you have to change it on the other side of the link. On switch B also we have to change, otherwise it will keep throwing error every 60 seconds. Let me show you that. Here also show interface trunk. You can see now it is trunking. We did not configure trunk on B, but it is trunking because of negotiation. In this you don't see that N.
Yeah.
Here it is because of negotiation. We did not configure. The default is auto. We did not on the trunk mode. It was auto by default. So through negotiation, it is forming trunk. And here also native VLAN is 1. You have to configure native VLAN on both sides. Now let's go and configure on switch A native VLAN trunk. Interface F0/1 switch port native VLAN 10. We have not created the native VLAN. Let us first create it. VLAN 10 name unused. Likewise, let me also create on switch B VLAN 10 name, any name you can give, giving unused. And now I'm on switch A. Let us go and assign native VLAN. Switch port trunk native VLAN 10. Boom. And as I said, if you don't configure on the other side, it keeps throwing error. You will see that now. They keep negotiating, and this guy says, my native VLAN is 10. The other guy says, what? My native VLAN is only 1. You'll see that now. Before that, quickly check show interface trunk. See, this is still saying 1, whereas this one show interface trunk, this says my native VLAN is 10. Switch A has got native VLAN as 10. See, CDP has discovered that native VLAN is mismatching. Native VLAN mismatch discovered on F01. The local is 10, whereas the switch B, see, it even shows the host name. CDP can discover the host name for you. It says the one with the host name SW_B on fast Ethernet 01 is using VLAN 1. Yep. So have to, every 60 seconds it will come on both the switches. So we have to match interface F0/1. May I know the command?
Which command?
The command to put native VLAN 10.
VLAN.
No. Switch port trunk native.
Switch port trunk
VLAN
native VLAN 10.
All right. So